Nice to meet you all in one more video. Today I am with the summary of the lesson Energy from the Sun. This is chapter 2 from the social textbook of 8th standard SSC board Telangana and Andhra Pradesh. Let's see what the lesson is all about. Now we see there is a variance of temperature from place to place and from time to time. That is, it is cool in the morning and during the daytime it gets warmer, and it's hot in some places and it's cold in some places. So there is a variation of temperature from place to place. This variation of temperature from place to place causes winds and rains. That is, the air from the high pressure area moves to the low pressure area. We have variation in vegetation and animal life. According to the temperature, the plants that grow in that region and the animals that grow in that region also differ according to the climate, according to the weather of that place. Right? And now we have the greenhouses. Greenhouses are artificial atmospheres created in order to plant, in order to have a certain growth of plants. So here we see the artificial environment created for the growing of plants. This is called as greenhouse. Okay, so the energy which is constantly emitted by the sun is known as solar radiation. That is, the energy coming from the sun is always constant, but the temperature on the earth differs according to certain factors. Those factors we are going to see in this lesson. We can see and feel some aspects of this energy. This energy means the solar radiation. We can feel certain aspects, certain characters of this solar radiation. That is, heat and light, we can feel them. But there are many other forms like ultraviolet rays, UV rays, radio waves, X-rays from the sun, which we can neither feel nor see because they are not into our range of looking at them. We cannot feel them. The solar radiation received from the on the surface of the earth is called insolation. That is, the energy is released from the sun. That is radiation. That is, by the time the solar radiation reaches the earth, there is a huge lot of change in this energy. Let us see what is that. 1/3 of the solar energy is reflected back by the earth's atmosphere. Whatever comes is again reflected back towards the sun itself. Further, some more portion of the earth energy is scattered and absorbed in the higher reaches of the atmosphere. Some of the energy, the solar radiation, is absorbed by some part of the atmosphere. In fact, some of the harmful rays of the sun, like the UV rays, don't reach the ground, and this has made life possible on the earth. So UV rays are very, very harmful for the human beings. As these rays are reflected or absorbed by the atmosphere, we are living on this earth. If at all UV rays come onto the earth, we won't be living on this earth. Some amount of solar rays are also absorbed or reflected away by clouds and smoke. If there is cloud or smoke in the atmosphere, that also absorbs some part of the energy. That is why it is very cold during the cloudy days. It absorbs all the radiations. And then we go to the next one, that is sun's rays and earth's surface. Even the rays that reach the ground do not heat the earth's surface uniformly, because the earth is not a plain surface. It is a curved surface. You know, the earth is spherical in shape. Now remember, you put a kadai on an oven. So which part gets heated? The bottom part, which is nearer to the oven, that gets heated, and the rest of the part are heat, but not as hot as the middle part, because it is in the curved shape. The same way, the radiation reaches the earth, but the heating on the earth is not uniform because the earth is in spherical shape. It has a curved surface. Okay, the sun rays fall at about 90 degrees on the equator. They fall slantingly towards the poles. This is called angle of incidence. So as you see in the picture here, the sun's rays fall directly on the equator, whereas the same ray of sun has to go till the pole. So it goes in an angle. So there is less heat going towards the other regions other than the equators, because the slanting rays, the more the angle of incidence, the lesser the unit of heat the area gets. Rays 0 degrees 100 units if at all. Insolation at the equator is 0 degrees, then at 45 degree that is 75 units, 66 degree 50 units, at 90 degree it is 40 units. So the more the region is away from the radiation of the sun, the lesser the heat it gets, right? Equatorial regions are not as warm as the regions immediately north or south of them, because there is usually cloudy days. After the midday, the sun rays fall on the ground, and less sun rays fall on the ground rather than the equator. The areas beside the equator get lot of heat. The angle of incidence constantly change. Thus, the angle of incidence increases in the north during the months of November, December, and decreases in the month of May and June. This is because the earth rotates around the sun. This angle of incidence also doesn't remain the same. It keeps changing from one time to another period of time. Then land is considered as a good conductor of heat, whereas water bodies are different. What happens is land gets heated soon and it cools off soon. Water gets heated late and it cools late. So this while land gets heated and cooled quickly, oceans will take time to heat and cool. This is what causes the land breeze and the sea breeze. So we find that there are moderate climates in the seashore region. The sun rays first heat the earth's surface. This in turn begins to radiate heat, which heats up the air around us. First the earth is heated, then area around the earth is heated. That is why it is warmer near the surface of the earth compared to the places of higher altitudes of the atmosphere. So as I told you, when the radiation of the earth, it doesn't heat it. After reaching the earth, the heat is transformed. So in that way, the hill stations, the mountain peaks are cooler. The temperature there is cooler than the surface of the earth, because first the insolation happens at the surface of the earth. Heating happens at the surface of the earth, and slowly it goes to the mountain regions. Then if the entire heat is not radiated back, whatever is coming from the sun, how much our heat is coming from the sun, the whole heat should be radiated back to the space. If it is not radiated back, then every day the amount of heat that remains will accumulate and it will become hotter and hotter. If the amount of heat which comes from the sun is not given back to the space, the earth's temperature gets hotter and hotter. On the other hand, if the earth received less heat than it gave out in radiation, it would get cooler and cooler. So happens here, the earth's temperature goes cooler and cooler. If the carbon dioxide proportion in the atmosphere increases, then less heat will be radiated, causing an increase in global temperature. This is called global warming. That is, when this heat is going out of the earth, while the radiation is given back to the space, in the middle, if the carbon dioxide gas is coming and stopping these radiation to go out, automatically these radiations won't go out, and automatically the temperature of the earth goes up. This is called as global warming. Because of this, the ice caps and all are melting, and that is how we are getting the effects of global warming. The sea level increasing, water of the sea level increasing, and the fresh waters and sources and all going dry.